It is a few seconds past 1:20. Our first speaker is Joachim Dahlstedt, now with BEA, formerly with FPL Virtual Machines.
Thank you. So it's not the 15th of September, so I'm going to talk a little bit about JRocket, and I'm going to talk a little bit about one of the areas that we are right now investigating, trying to develop within the VM, and I think I really appreciate your help in where we're going. So before we begin, just for the people in the room that haven't heard so much about JRocket, a little bit of background about what JRocket is. So it's a Java virtual machine. It's server-centric. It's always been, the goal is not Nokia's mobile phone. The goal is not really client-side Java either. It's server-side Java running big applications on big iron. That doesn't mean that we can't run on the desktop, but that's what it's focused on, is on the server. So it's Java compatible. We are a Sun licensee, so basically we ship the Sun libraries and then we ship our VM on top of the Sun libraries. It's available free of charge as any other Java virtual machine. It uses adaptive optimization, like anyone else, in the areas of code generation, memory management, locking primitives. So all the normal standard things that you would expect a good Java virtual machine to do. It has this built-in observability that we've built in from day one that allows you to get feedback on what's going on within the VM, what's happening, garbage collection events, profiling events, etc. That are always dynamically, that you always dynamically can turn on. A little bit more in detail. Code execution. We don't have an interpreter. We have a Git compiler and a dynamically optimizing compiler. There are no real. The only decision here was an early design decision that we really didn't want to build both an interpreter and a code generation pipeline. So we went for one code generation pipeline that can do both the Git compilation and then the slower optimizing phase. We have the ability to save the generated or optimized code to disk and later reuse that. In practicality, it has some usability problems that we are solving right now, so it's not something that we really recommend for production. Because of the way that you have to specify where the file should be, etc., it makes it very uncomfortable for users to use it. But that's an area we're continuing our efforts. Memory management. We have concurrent and stop-the-world garbage collectors, as any production VM should have, I think. You can decide if you want it to be single-spaced generational. We have the ability to switch garbage collectors on the fly. So we have this adaptive optimization process where we're trying to find out what is the best garbage collector for this system. And then we adaptively tune to that. So the user can specify what kind of pause time am I looking at, what is my pause time target. We don't care about the pause times, I only want throughput. And we're going to analyze the behavior application and adapt to that. So in summary, most of the features that we have are very similar to what you'll find in the IBM JDK or in Sun's hotspot. So that leads me to the future. But before I get there, I just want to comment about a little thing, setting the scene for this. What I see right now when we analyze customer applications or benchmarks or anything is that performance is getting good enough. I very seldomly hear someone saying the code performance is an issue. People are normally pretty happy with the code performance. We heard it from Kari, we heard it from Hans Christian earlier that, well, code performance doesn't seem to be such an issue, and I think I agree. I very seldomly hear any problems about it. Garbage collection is still an issue, but a lot smaller issue than it used to be. I mean, we can run with a 12 gigabyte heap, 1.5 gigabyte of live data, and we have pause times that are well below a second for a stop-the-world garbage collector. So it's on a 4-way titanium-based system. So it's not like we've gotten a lot better than we used to be a couple of years back. Of course, memory footprint is still an issue. We have problems reducing the side. We have been focused on the server side, but people are running multiple applications on the same system, and they are running into different kinds of memory footprint problems, even on the server. But all of this, I think, is leading to the point where when I look at the benchmarks before, you could find one thing and you could guess, oh, that's taking all the time for this custom application. You could go in, you could spend 2 days, and you were running 30, 40, 50% faster at least. Nowadays, it's a lot harder. There are hundreds of places that show up as small little points of things that you can do something with. And they're a lot harder to attack. We call this friction. And it's hard to attack those problems, and it takes a lot of time. And we spend a lot of time working on that. So things are moving more slowly in those areas. And the number of optimizations that we still can do is still infinite. So that leads me to this dilemma that we have. The compiler writes dilemma, there will always be more optimizations. So we have an infinite list of things that we can do. And then the question for us, as virtual execution environment specialists, has to be, what are the things we should do from this infinite list? We have to do some sort of selection. What are the things that we want to focus on that we think are most useful for the applications that exist today? I don't think it's code performance, because code performance is not really where the problem is right now. Okay? So
just a clarification, by code performance, you're really talking about what the JIT does. You're not, I mean, we've talked about issues in terms of the overhead and libraries and so on. So
yes, I'm mostly talking about business logic just running generated code.
right. So I mean, there is an opportunity. I mean, we've heard in the past for improving code performance of calls through multiple levels of libraries.
Yes.
But when you're talking about code performance, at least I'm assuming you're thinking about what a typical JIT compiler would do.
I am.
Yeah.
But in general, I think the thing here that I want to get at is that there are a lot of performance things we can do, but let's look at this from a little bit different perspective and see if it's really we that should be doing this work that is most efficient, that we need to do right now. So when I started building VMs, I thought the world looked like this, roughly. You had the hardware below somewhere, then you had some, let's do that as some sort of overhead, and then you have some overhead between the VM and this hardware. Above that, if you were building a large server-side application, you had a lot of layers that caused a lot of overhead. And my goal was to make it look roughly like this. Remove most of the overhead between the VM and the hardware. Remove almost all of the layers between the applications and the VM. And just make this run fast. And if we look at where we are today, I think we've come very close at reducing the overhead between the VM and the hardware itself. I think we've done a very good job of this. But what I still see is that a lot of the layers between the VM and the applications are there. So I will now go into a little bit and discuss what I see in that layer and why I believe that that layer still is so high as it is. This comes to what I wanted to talk about and why I didn't want to get distracted by code performance. My belief is that we need to share the performance burden with the developers of normal Java programs. We have to be able to translate our problems into something that they can understand. And why am I saying this? Well, can't we solve these problems ourselves in the virtual execution environment? I will show you why I think we cannot solve those problems. And finally, I will also talk about why we have to do this translation. Why can't we just send them the raw data, the performance counter, whatever it is? Why do we have to do something more than that for the developers to help us solve these problems? First of all, why can't we solve all the problems? Well, first of all, at this point at least, we cannot attack the algorithmical inefficiencies in programs. We can change a bubble sort to a quick sort. We can change, in general, a linear search to a sort of binary search or something like that, or hash table lookup or something. We cannot attack memory leaks, or I would probably say memory growth situations. If someone puts something in a hash map, and they put another thing in the hash map, and they keep putting things in the hash map, there is no way for us to know that you really don't want to use them anymore. We keep them around in that hash map. So we can't attack the memory growth problems. If someone has a very, very big cache, and they say they really want to have this big cache, we can't really remove it from them.